Gotta get that. 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 Gotta get that.
Hey boys and girls, welcome. Today is a nice day here at Math Hands. Today we're going to learn one of the promises of trigonometry was that we could take a tree, for example. Here's a nice little tree, and we could in theory just stand over here away from the tree, and just by looking at it, all we do is just glance at it, and boom, we'll know exactly how tall the tree is. That was one of the great promises of trigonometry, to be able to find out this height for the tree without actually having to climb the tree. By now we have enough tools where we can actually introduce this small little taste of it and show you how it works. Before we do that, it's going to be nice review what we did last time, and then we will talk about the details needed in this little trick here, and then we'll get down to business and actually measure the tree just by looking at it. Okay, how does that sound? Good. All right, let's get to business. First, a little repeat and review from last time. Last time we studied the Pythagorean theorem. Sometimes people call it Pythagorean, sometimes people call it Pythagoras' theorem. Whatever you call it, it's okay. But basically it said that if you have a triangle that is a right triangle, one of the angles be 90 degrees, and you have sides K, R, and P, for example, then it is always the case that K squared plus P squared is equal to R squared. Okay? That's for Euclidean triangles in flatland. And one of the major benefits for the Pythagorean theorem brings you is the fact that anytime you've got two of the sides, you can always figure out the third side using the Pythagorean equation. For example, here's a silly little example. Suppose you take the same problem here. Suppose this one is 3 and this one is 5, and you want to know R. Let's call it X. Then you could say, well, I know two of the sides, I can figure out the third one using Pythagoras. 3 squared plus 5 squared is equal to X squared. And that would mean that 9 plus 25 is equal to X squared. And that would mean that X squared is equal to 34. And that would mean that X equals plus or minus the square root of 34. That's what we did before. We had this premise here. Hey, Pythagoras is good because every time you go two of the sides and you want to know the third side, it's Pythagoras time. Okay, that was the point of it. And here I'm proposing something even better than Pythagoras, something beyond Pythagoras, the next thing beyond Pythagoras. And that is the following idea. Ready? This is a repeat and review from last time. Today we're going to take it up a notch or two. We're going to up the antes to the following idea. If you know the ratios, if the ratios of the sides of the triangle are known, oh my goodness, if the ratios are known, we're in business. All you need is one side. One side is all that's needed. This, my friends, this will be the premise for today's lecture and the next day's lecture and many lectures after this one. This is one of the fundamental ideas in trigonometry. If you know the ratios between sides of the triangle, for example, if you know a certain angle and you know it makes a triangle, and if you know the ratios there, you can figure out everything about that triangle, so long as you know one of the sides. That right there, this is, I can't emphasize how important this is. Maybe I should highlight it. This is how important it is. That's it right there. Okay, super important. You didn't see that before, huh? All right. So let me backtrack just a second. Last time, if you wanted to solve this triangle, two sides were needed. How many? Two. Any two of the right triangle. Two sides are needed, and Pythagoras would deliver the third side for you. Today we got something better. If you know the ratios, only one one side is needed. That's all. Just one side, and from one side you can figure out all three sides. You guys get it? Let me explain that again. For Pythagoras, two sides are needed. Pythagoras will bring you to the third one. Today's idea, if you know the ratios, all you need is one side. Okay? Well, talk is cheap. Let's do it. So suppose you, let me tell you a famous case in which we do know the ratios. This is called the 30-60 theorem. And the name is actually very descriptive because it applies to triangles where one of the sides is 30 and the other sides are 60 and 90. Of course, 30, 60, 90 to make a total of 180. Okay, so here's the 30-60 theorem. It applies to triangles that are 30. One of the angles is 30, the other one is 60, and the other angle, of course, is 90. So it only applies to right triangles. Okay, but not all right triangles. They have to have 30, 60, and 90 degrees. Okay, that being said, it says the following. If you've got a triangle here, where one of the, of course, it's got to be a right triangle. Well, I said right triangle. And if one of the angles here is 30 degrees, let's say this one is 30 degrees, and this one over here is 60 degrees, then on this one, the biggest thing we can say here is that on this one we know the ratios. That's one of the important ideas of today. The fact that on this one the ratios are known. Let me make that super important. Ratios are known. Take that. And here's how we know them. First of all, we're going to identify these sides here. All these triangles come with three sides usually. The one across from 90 degrees is always called the hypotenuse. Okay? That's tradition. Specifically for this triangle, for a 30-60 triangle, away across from 30. See, little angles make little sides. Bigger angles make bigger sides. This is 30. It makes a relatively small size. This is 60. It makes a bigger side. This is 90. It makes an even bigger side. So across from 30, you would always find what I would call the smallest side on this triangle. Across from 60, I would call this one the medium size side. Okay, across from 30, the small one, across from 60, the medium one, and across from 90, the hypotenuse. Now, the absolutely crucial thing here is that on a 30-60 triangle, the ratios are known. Well, they will be known by the time we get done with this. Here's how we know them. Across from 30, you'll always find the small one, and this one is always half of the hypotenuse. Again, the small one is always half the hypotenuse on a 30-60 triangle. So I could say it this way. I could say the small one is equal to half the hypotenuse, or I could say it this way: the hypotenuse is always twice the small one. These two things are saying the same thing. Or I could even make a little picture of it, telling you exactly what the relationship is. The relationship is like this: to go from the small one to the hypotenuse, all you do is multiply by 2. Okay? All these things say the same thing. The small one is half the hypotenuse. That says the same thing as saying the hypotenuse is twice the small one. That's it, and I'm trying to indicate that by saying the small one. If you want to go from the small one to the hypotenuse, all you do is multiply by 2. To go from the small one to the medium one, all you do is multiply by the square root of 3. Okay? This is meant to be multiply, not x. This is times. Multiply. Of course, if you wanted to go backwards from the hypotenuse to the small one, you would divide by 2. To go this way, you multiply by square root of 3, and to go backwards, you would divide by square root of 3. Okay? That's what I mean when I say the ratios are known. And if the ratios are known, all you need is better than Pythagoras. For Pythagoras, how many sides were required? 2. 2 sides were required so that you could figure out the third side. For whenever the ratios are known, all you need is one side. And for a 30-60 triangle, we know the ratios. The ratios go like this. The small one is half the hypotenuse, and the medium one is the square root of 3 times the small one. Watch this. Talk is cheap. Let's actually do one. So suppose you've got a triangle here. I don't know, something like that. That is the right triangle. And suppose that this side, this is 30 degrees. And this is, of course, 60 degrees. Oh man, I told you guys to turn your phones off. Alright, so across from 30, let's do yellow. Yellow's mellow. Across from 30, suppose this is 5. Let me tell you again. The ratios go like this. To get the hypotenuse, all you do is multiply by 2. So if this is 5, to get there you multiply by 2. That would give you, here, you multiply by 2, and that would give you 10. Okay? To get the medium one, all you do is multiply by the square root of 3. So this would be 5 times the square root of 3. See that? I make this stuff look easy. That's why they pay me insane amounts of money. Okay? Watch this. I'll do it again. Everybody got that? Suppose that this time you knew that this side over here was, I don't know. This side was 7. Again, what's the point here? When you know the ratios, if the ratios are known, all you need is one side. Okay? For a 30-60 triangle, we know the ratios. Here's how the ratios go. To get from the small one to the hypotenuse, all you do is multiply by 2. So let me think, 7 multiplied by 2, well, that would be 14. Can't believe how easy I make this stuff look. Can't believe I get paid to do this. Okay, this is the medium one. To go from the small one to the medium one, all you do is multiply by the square root of 3. So this would be 7 times the square root of 3. You see that? So easy. Alright. And you think, well, that was too easy. What if it was fractions or anything like that? Well, same thing. If it was fractions, suppose it was 2 9ths. Okay? No problem. As long as the one you know is the small one, see the one across from 30 is the small one, I know the ratios from small to hypotenuse is multiplied by 2. That's the ratio. I know the ratio from the small one to the medium one is multiplied by the square root of 3. So this would be 2 over 9 times 2, which would be whatever. I don't even care. This would be 2 over 9 times the square root of 3, which would be whatever. I don't even care. Well, you could compute it or estimate it if you want. That's for the birds. But anyways, that's exactly how knowing the ratios gets you everything on a triangle. Now, you may think, well, what the hell does that have to do with the original problem? Well, you're not ready yet. Let's keep working on it. Again, here's the point we got to drive home today. Okay? Pythagoras, all you need is 2 sides. From 2 sides, Pythagoras delivers the third one. Nice. Ratios, even nicer. On ratios, all you need is 1 side. From 1 side, the ratios will deliver the other 2 sides. Nicer, buddy. Example, on a 30-60 triangle, we know the ratios. The ratios are, the small one is always half the hypotenuse. The medium one is always square root of 3 times the small one. And we did a few examples. Now let me switch it up a notch or two. Let me switch it up a little bit. Take it up a notch or two. What if you weren't given the small one? What if you were given, say, the hypotenuse? Suppose you're told that this one is 30 units long. Whoa. 1 side is given. How are you going to figure out the other 2? Well, it's easy. To go from the small one, this is the small one because it's across from 30. This is the medium one because it's across from 90. Okay? I can put it here. We just established that to go this way, you would multiply by 2, right? Well, what if you had to go the other way? Oh, I made that disappear. What if you had to go this way? Well, to go this way, you multiply by 2. To go this way, you would divide by 2. You get it? That makes sense. To go this way, you multiply by 2. To go this way, you would divide by 2. And then, of course, to go this way, you still multiply by the square root of 3. So let's do it. Talk is cheap. 30 divided by 2, that's 15. I told you. See why they pay me? I told you. Divide by 2. Then to go from the small one to the medium one, you multiply by the square root of 3. So it would be 15 times the square root of 3. And there you go. Told you. All you need is 1 side. one side. If the ratios are known, all you need is one side. The ratios will deliver the other two sides. Just want to try it again? That was so fun, we could try it again. Let's try it again. What if this time the only side that was given was the medium one? What if somebody told you, hey, this side over here is, I don't know, 10 units long? Whoa. How did you do it then? You got to think about it. You got to think about it because we knew before that to go this way, you would multiply by the square root of 3, right? But now we got to go that way to go from the medium to small one. So to go from the medium to small one, what we got to do is not multiply by square root of 3, but divide by square root of 3, of course. And so this would be 10 divided by the square root of 3. And of course, to go this way, you would multiply by 2, as usual. So that would give you 2 times 10 divided by square root of 3. And there you go. I know some of you guys may be thinking about rationalizing this. Forget it. Rationalizing is for the birds. Okay? Beauty is the first test. There is no permanent place in mathematics. There's no permanent place in the world for ugly mathematics or ugly procedures. You know, rationalizing the denominator is ugly. Forget about it. It's for the birds. Anyways, so the point is, you know, these ratios tell you everything. Okay? All right. From the top. How is this going to help you measure the tree? We don't know yet. What's the big deal with Pythagoras? Well, many big deals, but one of the big deals is if you know 2 of the sides, Pythagoras will deliver the third one. Nice. But if you know the ratios, it gets even nicer. All you need is one side. From one side, if you know the ratios, all you need is one side. From one side, the ratios will deliver the other two. A very, very, very special example of a triangle where we know the ratios is on a 30-60 triangle. On a 30-60 triangles, the ratios are very, very special. They go like this. To go from the small one to the hypotenuse, you multiply by 2. To go from the small one to the medium one, you multiply by square root of 3. Okay? All bets are off if the triangle is not 30-60. Examples? We did a ton of them. Where every single time, all you need is one side. From one side, the ratios deliver the other two sides. Nice. Okay. Enough talk. Talk is cheap. How in the world would that actually help you solve this one? Well, I think we're ready. Sorry, I lied. We're not ready. Can't believe it. The other thing, too, to figure out is, the other super important question is why? Why in the world, where did we get this from? That the ratios are twice as hypotenuse, and on the medium one is, the hypotenuse is twice as small, and that the medium one is square root of 3 times the small one. Where did that come from? God? Who? One of the things that we're going to emphasize in this course is that we don't ever want to just take things for granted. We want to understand things, not just memorize it. Okay? Memorizing is okay if you're still not potty trained. But if you want to grow to the full potential of your human beingness, we want deeper understanding. We want to enjoy our lives. Okay? Enrich our lives, that is. You only live once. But if you got to make sure it's enough. Okay, stay thirsty, my friends. So, we want to know why this is. And then we'll come back to this one, okay? Okay. So here's the following question for you. So I've got a triangle here. Let's say it's a let's say it's a 30-60 triangle. 30-60. And I know that this is H, the hypotenuse. I'll call this the small one, and I'll call this one the medium one. And what I want to do is take logical steps, perfection, and beauty and reasoning to argue or to persuade or to make an appealing, convincing sequence of statements that lead you to believe exactly what I promised, that the hypotenuse is equal to twice the small one, and that the medium one is equal to the small one times the square root of 3. This is where we have to. This is the goods that we have to deliver. So this is where you start. This This is the start. You can start by assuming this, okay? This is the end. Once you've delivered the goods, you're done. Okay, this is where the creative process takes place. This is your playground right here. Okay? Why? Why is it that all you're allowed to start is with the assumption that you've got a 30-60 right triangle and make logical steps, perfection, and beauty and reasoning until you deliver the goods. Got it? Okay, so what do you guys think? Are you afraid? You got the look of fear in your eyes? Don't be afraid. You're in good hands. That's why they pay the hands. Alright, let me see. So the idea is really quite famous. Here's how you get there. Let me get all this stuff out of the way. Gone. Okay. So here's the idea. We could, let me think. What we do is we make another copy of this triangle, and we make another mirror copy and put it right next to it, beneath it, like this. And, well, has to be exactly the same as that one. Whoa, what did I do? OMG, what a beginner. Let's try it again, Mr. Beginner. We make another copy of this triangle. Exactly the same as that size. So if it's the same size, then this one will have to be H as well. And this one will have to be small as, or the same size as this S. If this side is S, then so will this one be S. And but something peculiar happens when you draw a triangle like that. Look, if this is 60 degrees, then this is 60 degrees too, because all you do is make a mirror image of this on the other side. If this is 30, then this is 30. And lo and behold, what you've got here, what you have here on the sides is this triangle right here is in fact an equilateral triangle. 60, 60, 60. All sides are the same. Because it's an equilateral triangle, all sides are the same, so therefore this one right here must also be H, H, H. You get it? This tells you that the H must be equal to two of the S's. Each S is the same, and two of them together added make up an H. That tells you the first part of the 30-60 theorem. It tells you the ratio between the hypotenuse and the small one. It tells you that the ratio is 200%. Hypotenuse is 200% the small one. Or said differently, the small one is 50% of the hypotenuse. And half of our task is already done. Check. Now what do we have? Now we have that on a 30-60 triangle, so far we know that if this is 30 degrees and this is the small one, then this one is twice the small one. We just explained the argument for that. Now what we need to do is figure out how about the medium one. So we got that this one is multiplied by 2. Multiply by 2. Alright, what about that one? Huh? We have to show that the small one times the square root of 3 is equal to the medium one. Well, to do that, we use Pythagoras, of course. Okay? Pythagoras says when two of the sides are known, you can always find a third one. So if you know that this is the small one, you know that that one's twice the small one, and you want to know how is this one related to these other two sides, just slap down a little Pythagoras statement here. Medium squared plus the small one squared is equal to the hypotenuse squared. Hypotenuse is twice S. Stop me if I'm lying. So then m squared plus s squared is equal to 4s squared. Subtract an s squared from both sides, and that would give you that m squared is equal to 3s squares by subtracting one of the s squares. This one had 4 squares, 1x squared, subtract one, that leaves you with 3. So m is equal to plus or minus the square root of m is equal to plus or minus the square root of 3s squared. So if we assume that m is a positive side, that will give you m and s are positive sides, s times the square root of 3. Okay? I told you. Didn't I tell you? This tells you that to get the medium one, you take the small one and you multiply by the square root of 3. And that explains exactly why. So, everything's coming together beautifully. Okay? Let's run it from the top. Pythagoras is nice. When you've got two sides, it gives you the third one. The ratios are even nicer. All you need is one side. If you got one side, the ratios will give you the other two sides. Nice. Well, we don't know any ratios. Oh, but wait, we do. On the 30-60 triangle theorem, we do know the ratios. On the 30-60 right triangle, we do know the ratios. The ratios are as follows. The hypotenuse is twice the small one. The medium one is square root of 3 times the small one. I told you, we know the ratios. And of course, we practice this many times. Again, the promise is if you know one of the sides, the ratios will give you the other two. And not only that, we didn't just learn how to use it. Of course, any old chump can learn how to use it. We actually proved it. We showed how exactly one could understand where it comes from. It comes from this, one way to see where it comes from is from this clever idea of making a reflection copy of this triangle on the other side, and the big one makes a right triangle. No. The big one makes an equilateral triangle where all sides are the same. That puts this side to be h, and h is s plus s. I told you. That's why they pay me. That took us to the second level where we know that the hypotenuse is twice the small one, and then from there we use Pythagoras to finish it off and conclude that the medium one is s times the square root of 3. Okay, let's cut to the chase then. What about this one? Let's get to the nitty-gritty. Well, here's how you could do it. Here's one way to do it, okay? Suppose you're trying to figure out the height. Here's what you do. You first stand right here at the trunk. Okay? You're standing there. And then you walk nonchalantly. You walk. Oh, by the way, you should measure this bottom distance here. Let's say we measure all the way up to here. And you walk, and you walk, and you walk. You walk, you're measuring, and then you just lay down and relax and chill. And then you just look up at the tree. Look up at the tree, and boom, suppose when you look up, you realize that this angle is exactly 30 degrees. And suppose that you've measured 50 feet, for example. 50 feet. Well, maybe that's too much coincidence. Yeah, you think so? Maybe you look up, that was 30 degrees, and maybe you measured, I don't know, 42 feet, whatever. Boom. As soon as you do that, you look at it, and you'll know exactly how tall the tree is. See how easy it is? Why? Well, let's think about it. Why is it that you would know how tall the tree is as soon as you've done that? Well, because now you've got a right triangle, and on a right triangle, this right triangle happens to be a 30-60 triangle, right? Stop me if I'm lying. 30-60, because you looked up and it was 30 degrees. By the way, if it wasn't exactly 30, you should keep walking, okay? Just keep walking until you see exactly 30. And what was the whole premise of this lesson? The whole premise of the lesson was, if the ratios are known, all you need is one side. One side is all that's needed, and you've got everything. So let's play this little game here. This is a 30-60 triangle. On a 30-60 triangle, we know the ratios. The ratios are, you multiply by 2 this way, you multiply by the square root of 3. That's all you should need. Alright, let's cut to the chase. Let's do it. Let's get to the nitty-gritty. Across from 30, you always find the small one. Across from 90, you always find the hypotenuse. Across from 60, you always find the medium one. Okay. To go from the small one, to the medium one, you would multiply by the square root of 3, right? But we're not going that way. We know the medium one, we want to go backwards. So if you wanted to go backwards, what would you do? Not multiply by the square root of 3, you would divide by the square root of 3, right? So, the small one, which happens to be the height of the triangle, oh, that's too many h's. It's not good when you have too many h's. Let's just call it the small one. The small one, it will be then, okay, To go this way, you multiply the square root of 3. To go that way, you divide. So therefore, the small side is equal to 42 divided by the square root of 3. Bam. That's why they pay me.